Hello everyone and welcome to day 17 of our low-level design course. Today's session is going to be quite exciting. We will be covering two very powerful design patterns, the proxy pattern and the chain of responsibility pattern. These patterns are critical tools in a software designer's toolkit, helping us control access to objects, add behavior dynamically, and design flexible, scalable systems. We will not only learn the theory but also look at real-world examples, relatable analogies, and of course some hands-on coding. So let's dive right in. First up is the proxy pattern. Now think about situations where you might want to control access to an object. Maybe it's a large object that takes time to create, or maybe the object is remote, or perhaps you want to secure access based on certain permissions. A proxy stands between the client and the real object controlling the interaction. It provides the same interface as the real object, so the client does not even know whether it's talking to the real object or the proxy. This is a brilliant way to introduce flexibility, improve performance, or add additional layers of behavior without disturbing the original object. Proxies come in different flavors depending on the use case. We have the virtual proxy, which delays the creation of a resource intensive object until it's absolutely needed, saving systems resources. There's the protection proxy, which acts like a security guard, granting or denying access based on credentials or conditions. The remote proxy handles objects that exist in different address spaces. Think about calling a remote server object as if it were local. Finally, smart proxies can add logging, caching, or reference counting. Understanding the type you need is key to applying the pattern effectively in real-world scenarios. Let's make this even more relatable with a real-world analogy. Imagine using a credit card instead of directly getting cash from your bank. The credit card acts as a proxy. It lets you make payments without needing direct access to your bank account. Similarly, an ATM is a proxy for bank tellers. It allows customers to perform transactions without actually interacting with a human. The concept is simple: provide controlled, optimized, and often enhanced access to a resource without exposing the resource itself directly. Now let's peek into how the proxy pattern is structured. We usually define a common interface that both the real subject and proxy implement. The proxy holds a reference to the real subject and implements the same methods but can add logic such as checking access permissions, lazy instantiation, or logging. This way the client interacts seamlessly with either the proxy or the real subject without needing to know the difference. This separation of concerns makes our system more maintainable, scalable, and easier to extend. Here's a quick code snippet to solidify the concept. Suppose we have an image interface and two classes, real image and proxy image. The proxy image only loads the real image when the display method is called for the first time. This saves precious memory if the image is heavy and not always needed. This is a perfect example of a virtual proxy. Notice how the client code remains simple. It just calls the display method without worrying about whether the image was loaded already or not. Proxies are widely used in real-world systems and frameworks. Hibernate ORM uses proxy for lazy loading, only fetching objects when their properties are accessed. Spring AOP internally uses proxies to add cross-cutting concerns like logging, security, and transaction management. In a microservices architecture, API gateways act as remote proxies, handling authentication, request transformation, and routing. Even web browsers use smart proxies to cache resources, improving performance dramatically. Once you understand proxies, you will start seeing them everywhere in system designs. Alright, quick knowledge check. What is the primary responsibility of a virtual proxy? Is it access control, lazy instant initialization, logging, or security? If you picked lazy initialization, you are absolutely right. The virtual proxy focuses on delaying object creation until necessary, optimizing resource usage, especially when dealing with heavy, costly objects. Now let's move on to the chain of responsibility pattern. This pattern is all about processing a request through a chain of handlers. Each handler decides either to handle the request or pass it along to the next handler in the chain. The big advantage here is loose coupling. The sender of a request does not need to know which receiver will handle it. This makes the system highly flexible and dynamic. You can add, remove, or rearrange handlers without changing the client code. To bring this to life, Think about a customer service center. You first reach a level 1 support executive. If they can't solve your issue, it gets escalated to level 2, then to a manager if necessary. Each level decides, can I handle this? If yes, done. If not, pass it onward. Similarly, in software, web frameworks use chain of filters or middleware to process incoming requests in a modular, clean way. In a chain of responsibility structure, we define an abstract handler class with a reference to the next handler. Each concrete handler implements the request handling logic and, if unable to process, passes it along to the next handler. This allows us to build flexible, dynamic processing pipelines. The client just initializes the chain. It does not have to worry about the inner details of how the request is handled. For example, imagine an application with a request approval workflow. You can have different handlers, manager, director, vice president, each checking if they have enough authority to approve a purchase. If a manager can't approve a high value purchase, the request moves up to the director and so on. The handlers are decoupled and the chain can be adjusted easily without modifying the request initiator. The chain of responsibility pattern is used extensively in modern software. In Java, servlet filters form a chain to pre-process requests, checking authentication, logging, etc. before the servlet even runs. In Node.js and Express, middlewares form a chain that each HTTP request passes through. Even event handling in web browsers, when you click something, the event bubbles up through a chain of handlers, giving multiple elements a chance to respond. Clearly, mastering this pattern opens up tremendous design possibilities. Now it's time for you to get your hands started. For today's exercise, try creating an authentication system using a chain of responsibility. First, check the password. If it's valid, then check the OTP. If that passes, check a CAPTCHA. Each step should be separate handler in the chain. As a bonus, implement a proxy for a large file download, ensuring that the file is only fetched from the server when someone actually requests it. Real practice will cement these patterns into your thinking. Let's recap today's session. The proxy pattern gives us a smart way to control access to real objects and optimize system performance. The chain of responsibility pattern decouples the sender and receiver, letting a request travel flexibly through a chain until it's handled. Both patterns improve the scalability, maintainability, and clarity of your system. Understanding these patterns will help us craft designs that are both elegant and powerful. For homework, I highly recommend you to go through the proxy and chain of responsibility chapters in the head first design patterns. Also try applying these patterns to your parking lot LLD project. Maybe use a proxy to manage parking ticket generation or chain of responsibility for access control levels in the parking lot. Exploring these ideas will deepen your understanding and truly prepare you for real-world system design challenges. Thank you for your attention.